Okay, so we waited for 10 minutes. I do believe that we have now a few more attendees that we had before. So, Anselm, what do you believe? Should we start our webinar today or should we wait a bit more?
Yeah, I think you can just start. Yes.
Okay, then I will unmute myself. I will share my camera. Hello, everyone. I also can see that recording has already been started. This is awesome. Hello again. My name is Anton Boyko. I'm happy to be here for the second time. And today we will be having a bit of a different topic. We will be talking about the automation and we'll explicitly we'll be talking about how you can automate your build pipelines with different tools and for different programming language. If you participated in my previous session that I delivered here, then you remember that I showed a very nice, very long presentation. We talked about a lot of stuff, and this session today will be entirely different. So today I will have 0 slides. I will have hands-on demos only. I do believe that you will enjoy that, and in any case, I will be extremely happy if you will share your feedback about our session today. Uh, yes, and as Anselmo put in the chat, I was also about to say that if you will have any questions, feel free to ask them in a chat, or what you can also do, you can raise your hand. Here there is a button in Teams under the reactions. You have the raise hand, and I to believe that I will be monitoring also the chat and I will be also monitoring the raised hands, and I will be really happy if we will be able to have a nice conversation here. On that one, let me share my screen here. And talking about automation in general, I do have a lot of, kind of jokes on that, what I believe the automation is, and so on and so forth. But to be honest, the person that summarized literally everything that you need to know about the automation was this guy, at least for me. Donovan Brown, he works for Microsoft. He is a really, really smart guy. He also has his own blog. Please go check it here. But the reason why I'm showing you the picture of Donovan Brown and his photo is that how he summarized everything that you need to know about the build automation. He was saying on one of the conferences, or maybe like actually not at one of the conferences, maybe he said that a lot, but anyway, I heard it from him on a conference that if you can show me how to do this in a command line, I will show you how to do that with the automation tool. This is a perfectly good summary of what the automation mean in general. Because let's say that we are creating an application based on a .NET, JavaScript, I don't know, like Python, whatever. We're creating that automation and we're creating that application, and at some point we want to build that application, create an artifact that we will be able then to deploy somewhere and run it there. So we want to have a way how we will create that application artifact. And technically, if you will kind of try to think about that a bit, then as a developer, you should already know exactly what needs to be done to create your application build. So let's say that let's say that I'm a .NET developer, and for a .NET, if you want to create an application build, what you will need to do, let's say that you just checked out a new repo to the new machine that you never worked before. You just checked out that repo and now you want to run that application locally. What you will do in this case, if you will start thinking about it, you will realize that you are basically doing a set of regular steps like The first step is to run the .NET restore command to restore your to restore your Nugget packages. The second step will be mostly running something like .NET build to actually build your application, to create some binaries that you will be able then to use to run your application, and so on and so forth. And when we are talking about the automation with Azure DevOps, with GitHub Actions, and basically with any other tool, there is just, like the automation itself, it's all about just writing the exact sequence of those steps. So for now, I would like to switch to Visual Studio Code. I do have a bunch of sample applications here, and we were talking about the .NET. So let's start with the .NET. So what I have here, I have my application, and as you can see, there are some folders like bin and obj. So I basically built that application already. But let's say that this is the clean repo. So the first thing that I will be doing here in this repo, and for now we're doing that locally, but then we will be I will show you how to do exactly the same steps, but as a part of your automation using the GitHub and using the Azure DevOps. We will be just running something like .NET restore command from the CLI. Sorry, it's maybe a bit noisy on my end, but it will be done really soon. Yeah, as you can see, everything was restored already, so the .NET restore command ran really fast, and it found that it's nothing to restore, which is cool. So the next thing that I can do, I can run .NET build in the same folder, and it will try to build this project. An interesting thing here is that what I can also do, I can actually add some extra arguments to my .NET build command. For example, let's check how I can do that. I will run .NET build -- help from the command line, and yep, now I can see that I can run .NET build with some options here, and what those options can be. I can specify explicitly, for example, that I don't want to restore anything because I already restored that. I can also specify, for example, that I want to create that build for a specific runtime or for a specific configuration. The configuration part is really important because, as you can see, by default, it will do that for the debug mode. So what I can do, let me just -c, I can run .NET build -c restore. So now it will basically do the same, but now it will build it for the, sorry, not the restore, what I was doing. No. Release, that's what I meant, sorry. There are two configurations for any .NET project, the debug and the release configuration. So yeah, I mean, like I can run it for the release configuration, and for the release configuration, it will produce the minified version of the build, which will consume less memory, less CPU, and so on and so forth. So now, the next question will be, what exactly do I need from all of those files to run my .NET application? I can go to bin folder, I can see, okay, restore, that was just a mistake. I can see that there is inside the bin folder, there is a release folder, there is a .NET 6 and some files over there. But those files technically are definitely not enough to run my application. That is why, if you never used that command before, I want to introduce you to the .NET publish command. So I can do .NET publish, and I can specify the exact folder to which I would like to publish my application. I'm typing -o out. So what will happen, it will create the new folder in my project root. It will name it out, as you can see here, out. And here I have now everything that I need to run my application. let's try to do that. Let's go to out folder and let's do something like .NET. Sorry, we don't need to do .NET run. We can just, I do believe, run the application itself. Yep, and I can go here. Let me just open it in a browser. Yes, and as you can see, some kind of a demo website. My application is working. I can switch between those two pages, so everything looks to be okay. One detail talking about .NET publish command is that actually I'm not sure, I mean, like what the exact experience with the .NET you are having, but anyway, let me just share this cool thing with you. On my machine right now, on my MacBook, what I do have the .NET SDK, so I can easily run any program created with the .NET, any application created with the .NET, and by default, the application that will be built with the .NET build or .NET publish command, those applications will depend on a .NET on your machine. But what you can do as well, let me just open the README file. It will help me. And what you can do as well, you can run the .NET publish with the self-contained flag, with the self-contained switch, and here you can specify that what you want to do. You want Microsoft to also basically take everything that is needed from the .NET runtime and make it a part of your package. So you can do something like this. I will just copy this command. So .NET publish -o out. So we will publish everything in this out folder. Self-contained means that the .NET runtime itself should be now a part of this build as well. What we can actually do, let me just open this folder in Finder. So what I want to check here, I want to check that the current size of this folder is about 8.5 megabytes. Okay, so 8.5 megabytes, the size of my application, but this application depends on a .NET that needs to be installed on my machine. Let me just remove this folder from here. Now I will run this command. I will ask to include the .NET, and also now I need to specify on which exact operational system and which exact architecture I will run this app. So in my case, I need to use Mac OS, and that will be OS X. So this is the command that I will be running. .NET publish to the output folder self-contained architecture x64 and operational system OS X. Run. Operation not permitted. Oh, yeah, sorry. Yeah, sorry. Let me just reopen the terminal because my terminal was in the output folder, and output folder was removed, and that's why I had that error. But anyway, I can run this command again. The same command, basically. Okay, it's done. So what we can go and check now, that this folder, as you can see now, is 100 megabytes. So it's more than 10 times bigger. It's like 12 and a half times bigger than it used to be before. But now it also includes the .NET runtime, so now I can run it basically on any macOS, even if on that macOS I don't have the .NET installed. If I need to run it on Windows, I can easily do that. Let's just modify this command a little bit. Let's use something like out win. So we will upload that, we'll publish that to the new folder. And here we will keep the architecture x64, and we will just use the general Windows operational system. But if, as you can see, if you want, you can build it explicitly for Windows 7, Windows 8, Windows 10, and so on. But let's do just general Windows. It will create a new folder. It will rebuild the project. It will again pack everything that we need. And in a few moments, we will see the results. Okay, the folder is here. Yes. So now I have this out win folder, and this folder is also 100 megabytes. So as you can see, the runtime and the binaries, they are more or less of the same size for each and every platform. I can do the same on Linux and so on and so forth. So I was telling you that, and now let's just do a quick recap. So what we remember from this first 15 minutes of the session is that we need to run .NET restore, we'll need to run .NET build, and we need to run .NET publish. Okay, so let's do and start, I don't know, let's start with the Azure DevOps, for example. I have an Azure DevOps here, as I also mentioned in the description for this session, is that one of the reasons why I'm basically explicitly talking about Azure DevOps and the GitHub here, because both Azure DevOps and GitHub, they both provide free pricing tiers. So if you would like, after this session, to go and try and check it at home, you will be able to create your accounts here and there, and you will be able to try everything for free. There are some limitations, but we will talk about those limitations a bit later. So this is the pipeline for my .NET application. Let's see how this pipeline looks in Azure DevOps. So there are actually a few ways how you can create that pipeline in Azure DevOps, but the modern way and the way that I will recommend you to do that is the YAML way. So basically, how to you are describing your build process in a file that sits there in the repo together with your source code, and this file will look like this. So let's try to go through this file and see what we have here. So the first one is the trigger, so and in my case it's none, which basically means that I will need to trigger this automation manually. I can have a lot of different options here. I can run this automation on every commit, I can run it on every pull request. If needed, I can specify a filter. For example, as you can see in my repo, I have a bunch of different applications. So if needed, I can specify a filter that I would like to run the .NET pipeline for new commit, but only if files that were changed are in this .NET folder. All of those things can be configured. Then I'm specifying the pool. So I'm specifying on each exact machine I would like this automation to run. And here it's Ubuntu latest. The current latest version is 22.04, something like that, but nonetheless. So I will be running this on Ubuntu. My first task here, I'm using the built-in task use.NET. This built-in task allows me to ensure that on my target machine, I will have the .NET SDK version 6.0, and the minor version, or like the patch version, I don't care about that. That's why it's X. And then, as you can see, I'm running .NET Restore, I'm running .NET Build. I'm even explicitly specifying the no restore switch, basically saying that I already restored my dependencies, so I don't need to restore them now. And then I run .NET Publish. An important detail about any pipeline that you will create is that On each and every pipeline, it works in a way that it downloads the repo, it do everything that was specified here in your steps, and then after the pipeline finished, it tries to clean up the machine, and it's more or less successful in that. It tries to clean up the machine and removes everything that was added during the pipeline run. Why I'm telling you that? I'm telling you that because there is a dedicated step here, the final step here, to publish your build artifacts. We do remember that because we're specifying here that we want to publish everything to the output folder, that basically means that everything that we need to run our application will be inside the .NET/out folder. That's why I'm using this built-in command publish pipeline artifacts. I will name those artifacts binaries. And this was the last successful run. It took 29 seconds. I can go here. I can see the logs that the first task that was added automatically by a convention is to check out the repo. So first of all, it downloads the source code. Then it runs the use.NET command. It ensures that the .NET SDK version 6 will be there. And then it started with those command line scripts. Here you can see line 11, .NET restore. Here again, line 11, .NET build with no restore argument. It was 0 warning, 0 errors. Everything was cool there. Now .NET publish, and after that I run this publish artifact command. And now if I will get back to the page where I have the information about the exact run of this pipeline, what I will be able to see, I will be able to see one published artifact here. So I can open it. I can expand it here, and I see everything that I've needed to run this application. Everything was uploaded. So what I can do now, for example, I can create my second pipeline, and I can say that my second pipeline will depend on my first pipeline, and my second pipeline will then grab those binaries and deploy them to my application server. For our session today, we're talking only about build automation. We're not talking about deployment automation. We may talk a bit about the deployment automation later, but the thing why I usually have those two separated is the following. So when we're talking about build automation depends on what programming language was used to create your application, because the automation for .NET, for Python, for Node.js, for Java, for PHP will be different. For all of those different programming languages, the automation how to build your app will always be different. But when we're talking about the deployment process, we don't really care on which exact technology we create our app. We mostly care about what will be the target platform for our deployment. During my last session, for example, that I delivered to this group, I was talking a lot about Azure App Services. So if you are deploying something to Azure App Services, you don't care. You can deploy Java, you can deploy PHP, whatever. The deployment itself will work fine. If you are doing something with the Docker containers and deploying something to your Kubernetes, then again, it will be more or less the same flow for any Docker container. You don't care, do I have a Java app? Do I have a Python app inside that Docker container? You care that you need to deploy that to your Kubernetes. So that's why today we're talking only about the build automation. Let's actually check how it can be done with the GitHub Actions. With the GitHub Actions, as you can see, I'm on my GitHub right now, and what I can do, I can go here and I have the same YAML files. Let me just open the YAML file for the .NET. in the edit mode, so it will render me this nice and cool UI. And this is the same set of not the same set. This is the same automation, but now we are using the different automation engine. Before we were using Azure DevOps, now we are using GitHub Actions. So here the syntax is a bit different. First of all, I'm specifying the name of my pipeline, which is .NET. Then I'm specifying my trigger on workflow dispatch, means that it will run only if I will trigger that manually. But again, if I want to trigger that automatically, if I want to add some filters and so on and so forth, that can be done easily. And now we have the set of steps. So first of all, we're saying that, again, we will run everything on Ubuntu latest, like with Azure DevOps. Here, explicitly, we need to add this task to check out the source code. In Azure DevOps, we can do the same explicitly as well, but it's optional. Here, it's mandatory. Here, we again set up our .NET SDK, and then we are running .NET restore command. We are running .NET build with no restore. We are running .NET publish, and then we are uploading our artifacts. I can go here to the actions, and let me just filter it out by .NET only, and let me show you how the build results page look like. So this is how the build results page look like. I can go here to my build, and I can, if needed, check all the logs. For example, I can open build, and I can see that the command that was run was .NET build no restore, and so on and so forth. And if I will go to summary screen, I will be able to see that the binaries as an artifact was uploaded, and I can download it from here and use it somewhere else. So as you can see, in general, those two pipelines, they were extremely the same. I will also provide you the link for the GitHub repo after the session, so you can go and check everything. And the first difference that I want to talk a bit, at least a bit about, is the way how the artifacts are exported. Because as you can see, when you exported that artifact in Azure, in GitHub Actions, you have one file, so it's basically one archive, the binaries archive. So everything that was in that folder was zipped and exported as one file. In Azure DevOps, all the files were exported separately. You can still, in Azure DevOps, download everything as a zip archive. As you can see, you can download everything as a zip archive, but still, that's the first difference that you need to know between GitHub Actions and the Azure DevOps pipelines. The second difference, which is also very important, I do believe, it's the difference on how they monetize or how they charge you and for what. So when we are talking about Azure DevOps, in Azure DevOps, you pay for what they called pipelines. What does it mean, pipelines? The pipeline mean that you will have an abstract virtual machine that will be able to run your automation. Okay? So, but on one pipeline, you can run only one job at the same time. What it will mean? It will mean that if you run, for example, on Azure DevOps, let's say if I will go and run 5 different pipelines, 5 different build definitions for all of my apps at the same time, if I'm willing to pay only for one pipeline, it will mean that I will be able to run those builds only in a sequence, because I will have only one abstract virtual machine in a cloud. So the first build, for example, for .NET will run, then the second build for, I don't know, like React application will run, and so on and so forth. And I will need to wait quite a long time. But at the same time, first of all, Microsoft will provide you for one pipeline for free. So you can use one pipeline for free in the limit of 2,000 build minutes, if I'm not mistaken, something like that, per month. But yeah, your builds will be always slower. If we're talking about GitHub, the GitHub will more or less work in the same way. It will also have a limit on the amount of build minutes that you can use per month. But the important part here is that the GitHub will not care about how many tasks you are actually running in parallel. So if on a GitHub you will, let's say, I don't know, like push 5 builds in parallel on a GitHub, they will always run in parallel. It may looks like the GitHub is better. I mean, like the monetization model is better, but there is also one thing worth mentioning here. So when you are buying with your own money, the pipeline for Azure DevOps, for example, that pipeline will work for Windows machines, for Linux machines, and you will always pay the same price. So you pay for kind of one parallel run, and you can use Windows machines, you can use Linux machines, it will always cost you the same. On a GitHub, you will need, as soon as you will run out of this free limit of 2,000 build minutes per month, you will need to pay for all of the build minutes that you will have after that. So on a GitHub, the Linux minutes, you will pay for them like regularly, but if you will need to run your pipeline on top of Windows machine, because you may still have some old legacy application that can run only on Windows and so on and so forth, then they will charge you double. So basically, for each minute that you will run your automation on Windows machine, they will charge you as if it was 2 minutes for the Linux machine. Why? Because GitHub needs to pay Microsoft for the Windows operational system licenses. So that's why you will need to pay for that additionally. But in any case, what you have, I mean, like for both Azure DevOps and GitHub Actions, you are also able to bring your own agents. This is a really kind of a cool option. We will not talk about that a lot now. I just want to kind of, show it to you really quick that, for example, on Azure DevOps, you can go to project settings, and here in the project settings, you go to agent pools, and by default, for example, you have Azure pipelines and the default. You can go to default pool, and you can click on new agent. And what you will be able to do, I'm running on macOS right now, but the same works for Windows, the same works for Linux. You are able to download the build agent. You have some short manual what you need to do to run that engine on your local machine, and now your local machine is connected to your own instance of Azure DevOps, and now when you run your builds, what you will need to do, let me just do it like this. When you will need to run your builds, let's say that I want to run the same builds, the same .NET builds here, but on my local machine. The only thing that I need to change is to change this guy here. I will just specify that now it will not need to use the Ubuntu latest default image. Now it will need to use, for example, my pool of resources, and that pool is named default. So here I was showing the default, but also you can create a new pool, call it something like, I don't know, oh no, yeah, for example, here, as you can see, I've already have something, so I can link it to that, but I can say that that will be something that is self-hosted. I can name it local, for example, create. Here I have my new pool with the name local. I can add my local machine to this local pool, and then let me just name local. If I will change it like this, save it, run it, it will run the next build on my local machine. The same works for GitHub, but for the GitHub, the configuration is not so easy, not so transparent. There is a manual, but that manual is a bit longer than the manual that you have here on this page. Okay, so that was for the .NET for the .NET web application. The other thing that you can also do with the .NET, you can do the client-side application. So the application that will run purely in the browser with the .NET. But because both of them are based on a .NET, the pipeline will technically look the same. So I have another pipeline which called Blazor here. And if I will open it, you will see that this pipeline is exactly the same as my previous pipeline for the .NET web app. There are a few differences here. First of all, I use the different working directory. I'm using the working directory Blazor because now it's just a different folder. But in general, I do believe that's it. So I'm running the same commands, but from a different folder. If I will open this run, I also have one published artifact here. And this artifact looks a bit different. I do have the web config file in case I would like to publish this application to the IAS web server, but then the application itself is within the www root folder. I have the index.html file, and that's basically it. And here under the framework, as you can see, I'm having a bunch of DLLs because what Blazor actually is, Blazor is the way of running your .NET directly in the browser. It uses the WebAssembly, so it will run only in the modern browsers. But anyway, different application based on .NET, still same build pipeline. Let's talk about something that is not native to Microsoft. Okay, as you can see, I do have a few more pipelines, and then I would also talk to you about some kind of interesting things related to the build automation as well. So let's start talking about Node.js. Okay, so the Node.js is something that is not native for Microsoft, but I mean, like, that statement may be true like 10 years ago, but even 5 years ago, I would really doubt that that was a really true statement. Microsoft now strives to be as open as possible. Let's check what I have here. Here, the pipeline looks a bit different. The first few lines are the same, and then the idea is the same. So I'm using the node tool action to ensure that I will have a Node.js installed on this machine, and I'm looking for version 18. Then I need to restore my packages. If you're familiar with the Node.js, you know that with the Node.js, you can do that with npm install or npm CI command. Another important thing that I want to mention here, talking about Node.js, is this attribute -- only equals prod. What does it mean? It means, let me just open my application folder here. It means that if I will take a look at my package JSON file, and my package JSON file usually describes everything, I mean, like all the dependencies that I have for my application, as you can see here, I have two areas for those dependencies. I have the regular dependencies and I have dev dependencies. In dev dependencies section, I usually put something that I don't need to run on production. For example, I may be using a Jest framework here to run some unit tests for my Node.js application. Running unit tests locally and running unit tests on, for example, during the build automation is really, really important, but I definitely don't need to publish the unit test framework together with my application to production. So that is why I want to ensure that when I will run the npm CI or npm install commands, only those which are here under the dependencies will be installed. And I'm doing that with this flag, dash only prod. So the thing is now it really depends on which exact framework you are using within the Node.js itself. I'm using Express.js framework, and here I'm explicitly showing to you how you can assemble the artifact that is needed to be published. So I'm creating a new dir. Explicitly, I'm calling that dir out, more or less in the same way as the .NET CLI will do that for me. And now I'm just starting to copy those files from my source folder to that out folder. Yeah, there's tutorials for latecomers. Yeah, that's exactly like that. So the thing here is that now I need to really understand. I need to really understand what I need to do, or I mean, like what exact files I need to run that application on production. With the .NET, we will run in binaries. With the Node.js, because this is not the compilable language, this is the language that needs to be interpreted by the engine itself, I need to put the source files. So I definitely know that I need files from bin, from node modules, public, routers, views, and also I need the app.js file. And then I'm running the same publish pipeline artifact command. The thing here is that I may also have, as I was saying, some extra files related to running tests, but I'm kind of avoiding copying them. The same I have for the GitHub as well. Now let's take a look at Angular and React, because Angular and React, they are working a bit differently compared to the Node.js. So let's start with the Angular. So again, the first step is the same, installing the Node.js tool, and then I'm running the npm CI without that extra flag, only production. Why I'm doing that? Let me open the package JSON for the Angular application. So if I will open a package JSON for the Angular application, you will see that I have some dependencies here, and I also have a lot of dependencies as my dev dependencies. But the thing with the Angular is interesting in a way that what Angular provide us, I mean, like the Google, what they provide us as a part of the Angular framework, they provide us with the CLI that is able to create a production build. So that's why here I'm running the npm run build, and what the npm run build will actually do, it will grab everything that is needed to run those to run that application in a browser, and it will always remove everything that is not needed automatically. So I don't need to do that myself. And when I will run npm run build, the dist folder will be created, and inside dist folder, the Angular folder will be created, because the Angular is the name of my project. And as you can see, as I'm showing it to you locally, everything that I need will be placed there. So It also a JavaScript-based platform, more or less in the same way as the Node.js, but with the Node.js, I don't have that capability as a part of my Express application, so I need to copy all of those files manually. With the Angular, I have it here. So yeah, when I will run npm run build, the next thing that I can do, I can run the publish build artifacts, publish pipeline artifacts. And if I will go here under the web app, as you can see, the same files as I was showing you in my Visual Studio Code. And again, I have the same for the GitHub. And if I'm looking at the React app, the React app works exactly the same with only one slight difference is that I'm also running npm CI, I'm also running npm build, but now the output folder is different because by default React will create a folder called build and everything will be exported to that build folder. Let me show it to you here locally. Build, yeah, this is, as you can see, everything that React will export. So this is how it works. And that was really the basics. But I also want to show you something that I do believe is a bit more interesting, but to be able to show you that, I needed to kind of ensure that you know the basics. So now let's take a look at some advanced things because those will work fine if you will need to run some, like some small project, maybe a startup or something like that. But in most cases, you need to have like a bit more ways how you can control on what will happen in your build automation. So let's check some advanced samples. I have another repo here. It's called pipelines. Here, what I have again a Node.js app. I took that explicitly because I wanted to show you something that is not really native for those platforms. But the thing here is I also have some dummy tests. So what we will be doing now, I will show you how you can do the build automation, how you can run tests, and how you can use some advanced techniques to work with that. So let's go for actions. Okay, let's start with the basics. So the basics are really, really simple. What I'm doing here, I'm running the npm CI command, and then I'm running npm run test CLI, which will trigger this run for those unit tests. Let me show you how it will look like. It will look like this. And the thing is that I do have tests and I run my tests here. So if I'll expand it, you see that in my console, I have this report that I had one test and that test passed and so on and so forth. But this is not really, like a convenient way on how to check those reports. So that's why now let's talk a bit about publishing not only artifacts, but also publishing some test results. So to do that, what you need to do? To do that, you need to change two things in your project. Let me actually open. Do I have it here? Yes. Oh, sorry, it opened on another monitor. Let me bring it here. So what I have here, I will show it to you locally for now. I have two different commands. I have test CLI and test trix commands because now I'm not only running unit tests, this time with a different framework, but I'm also using an exporter that will be able to generate a structured format. See the XML, the structured, in this case, XML file with my test results. So if you will take a look at this file, the most important node is results. And here, because I have one test, I have this unit test result, and I have the test name, for example, And where was that? I have an outcome that this test passed. Now I want to make this XML a part of my report. What I need to do for that? Let me open the second pipeline. So here there are a lot of tasks, both for GitHub Actions and also for Azure DevOps. Here I'm just using the GitHub Actions example that will allow me to grab those structured results and then output them as a nice report on my dashboard. How it will look? As you can see, it will create the test results, in this case, the test results node here on the left side. And if I will go here, it will show me that one test passed and so on and so forth. So I can see the raw output here, and this is a really, really cool thing to have. I can show you also a more complex example. Let me just a more complex example, that's the example for the .NET, but anyway, I can also show it to you here. This is one of my other pet projects, and on that pet project, I have a bit more than one dummy test. If I'm not mistaken, this pipeline. Yeah, let's open this run. And here, as you can see, test and coverage, it says that 100% tests passed. So I can open this one, and here I have a bit more fancy report in Azure DevOps. I have 99 tests in total, all of them passed. In total, they run for 13 seconds, and I can also clear those filters, collapse this panel, for example, and show you that those tests were also grouped by different test runs, different test suites, and so on and so forth. And I can go and check that, for example, unit tests on Linux, I had a test which called parse CSV. That test passed. If there will be some error messages, I will be able to check to see them here, stack trace here, and so on and so forth. So this is an extremely cool feature to have, and you should definitely aim to have those kind of reports in your pipelines. Let's go for another example, metrics. Let's say that you need to do something a lot of times, but with a bit kind of a different arguments. Let's say that you need, like I was doing here in my case, to build my application for different versions of Node.js framework. As you can see, I built it for Node.js 14, 16, 18, and so on and so forth. To be able to do that, there is a way of how you can define a parallelism strategy, and this strategy works like this. You are adding a matrix here, strategy matrix, and you are creating a variable, in this case node version, and you are specifying different values for that variable. And then I can use this variable anywhere in my scripts, and it will work exactly like expected. It will just create so many instances of this particular job as specified by this array of node versions. If I want to do a bit more complicated example, I can show you a bit more complicated example here together with the runners. So here, as you can see, I defined a matrix, and in the matrix now I defined two variables. Because I defined two variables, it will now do the following. It will create all the possible combination of all those different variables. The idea here is that what I wanted to show you, except of those more complex example of matrix, is that you can actually choose on which exact operational system you would like to run your pipeline, and before I don't remember exactly which year, sorry, but anyway, before some time, that was a feature that was available only for Azure DevOps. Now it's available on a GitHub as well. You can use the Windows-based build agents. You can use the Linux-based build agents, the Ubuntu-based, and also you can use a macOS build agents. The reason why you need to use the macOS build agents is because you may create some applications, for example, I don't know, like for iOS or something like that. The big idea here is that if you want to build an application for an iOS, for macOS, or for anything else that is a part of the Apple ecosystem, the only one way for you to do that is to build that application on top of the macOS operational system itself. So yeah, and now I'm creating the runs on, sorry, not creating, I'm specifying that it needs to runs on, and I'm taking values from this matrix. And the last build here failed, but I do believe that I fixed that already. So let me just run it again. And I will also show you that all of them will run in parallel. So I'm going here. As you can see, so 16 jobs in total will be created. So here you can see all of those 16 jobs. And as you can see, all of them are trying to start in parallel. They are not waiting for each other. Some of them are working. Okay, it seems like I didn't fix all of them, but nonetheless, let me maybe try to check what is the error message here and how I can fix it. Huh. Okay, so it seems like the Ubuntu 18 is a bit too old and it lacks some libraries. So we will do a quick fix, like in that joke. So, and the quick fix will be the following. We will just remove the Ubuntu 18 from this list. Let's also remove the macOS 10 for the same reason. I changed the file, and now let me try to run this again. I hope it will work this time. But the other thing, the other important point, which also worth mentioning when we're talking about build pipelines, is that, okay, here we are again talking about something simple. We're talking about how we can build a simple Node.js app, .NET app, Angular app, whatever. What if we need to build something that is a bit more complex? What if we need to have some really, like unique set of tools to run the actual build? I mean, like we need to have a unique version of operational system, a unique version of tools, maybe some extra tools that are not part of the default image that the GitHub and the Azure DevOps provides to you. What options do you have with that? So the option number one will be to create just a few additional steps at the beginning and use those few additional steps to basically install those tools that are required. And in general, that will work fine unless you need to install something that may affect the core operational system. In that case, the both GitHub Actions and Azure DevOps pipelines will block you from installing those. So technically, you can install some of the tools, but definitely not all of them. What you can do that can help you with that, you can actually, if we're talking about Docker containers, or not Docker containers, if we're talking about the containers itself, if we're talking about containers, you can create your own custom image. That custom image can have a lot of tools, can have basically all the tools that you need with the exact versions and so on and so forth. And from that image, you can actually do the following. You can ask both Azure DevOps and also the GitHub Actions. You can ask them to run your pipeline, but not on top of the virtual machine itself, but from within that container. It's actually super easy to do. I have a sample pipeline here on how to do that. It's this pipeline. So here I have two jobs. I have the regular job, which will run on Ubuntu 24 and which will just basically read one file in a console and show me what is the exact version of my operational system. And then I have another job which will also run on Ubuntu 22.04, but because I'm specifying here that I want to run it from within the container, I'm saying that please use an image from the Docker Hub that's called Ubuntu 18.04 and show me exactly the same information. So I'm running the same command, but here I'm also asking what is the current version of the operational system. Go into actions, go into this one, and let's run it again. I already run that before, but let's just run it again. The containers, those two jobs will run in parallel. Okay, so if I will open the regular job, if I will see what I have here, then in my log, as you can see, Ubuntu 22.04. So yeah, basically what we expected. If we will go to container and open the same line, here we have Ubuntu 18.04. What you can do here, I mean, like here, you can not only use the images from the Docker Hub, you can easily use your own private container registry, and you can use the images from that private container registry. You can connect them to your build pipelines. As I was saying, it works in both tools, in GitHub Actions and Azure DevOps. And yeah, in that way, if you need to run some really crazy builds, then you can ensure that you will use the exact tools with the container images. It's much easier to do it here rather than doing that in a different way. I can actually give you one of the examples how we were using that in one of my projects. I came up with an interesting idea in one of my projects. We were working on a quite big website. Maybe actually I told that story already on our previous session, but nonetheless, I will just repeat it again here then. So we were working on quite a big website, and when we deployed the new version of the website, it was really important for us to ensure that we will warm it up. So it was really important to ensure that after deployment, before we switch the traffic to the new version, we will we will kind of, click on some buttons, populate the caches, and so on and so forth. The old approach for us was the following, that the team that was responsible for the cloud engineering, that team creates some simple PowerShell script, and that PowerShell script just called using the HTTP client, just called some URLs, making sure that the site is actually up and running. But I came up with a kind of an interesting idea. I do believe that that was interesting. That I said, hey guys, you know what? What we have in the other team that is working on the same project, that team is measuring the performance of our website. So what they have the most crucial URLs already programmed in their performance tests. So let's do the following. Let's actually ask them let's ask them that they will share with us those Loa tests, and then we will be running the Loa test as a part of our pipeline, but we will not run them with the load that we expect to measure on production. Like, we will not run them with the million users load and so on and so forth. We will run the same test that will warm up the site with just 2, 3, 5, maybe 10 virtual users. And the team that was working on the performance tests, they were using the gmeter tool, and the gmeter tool is the Java application, which, as you can assume, by default is not installed on those agents. And we were trying to use a few different approaches how to put that gmeter tool in our pipelines, and the most easy approach was to use those container images. So we created an image with the gmeter installed, and we created a separate job that runs after the deployment, and that separate job that after the deployment connected to the repo with the performance tests, download the performance tests from there, and run it with the gmeter, specifying that we need to run it only with 10 users load, and in that way we warmed up our website. Why it was so important? It was important because at that point, we were able to ensure that if something will be changed in the URLs, if some new URLs needs to be warmed up and so on and so forth, then there is a high probability that the performance team will be working on that, and they will have the corresponding changes in their code. So we don't need, when the new URLs will come up, we don't need to update them in two places. We don't need to update them in performance test, and we don't need to update them in our warm-up scripts. We'll be using basically the same script for both. Okay, so that was it, and we are actually, yeah, we were able to more or less fit in 1 hour time slot, but nonetheless, I saw there are a few comments in a chat, but I don't see any kind of questions. At that point, what I do believe we can have, at that point, I do believe we can have like a more open session, like a more open conversation. So guys, if you have questions that you would like to ask about the build automation, about Azure DevOps, GitHub Actions, and so on and so forth, please raise your hand and we can talk about that.
Yeah. So guys, if you have any questions for Anton, kindly just unmute and kindly ask. Yeah.
While you're thinking on your questions, what else I can show you if we're talking about build automation and stuff? I can show you probably another thing. I do believe that I can use two pipelines here. Let's start with this pipeline. This is again for Azure DevOps, but most of the stuff that I'm showing here is the same for Azure DevOps and for the GitHub. So this is another pipeline. What I was doing here, this pipeline actually is ancient because when I was creating that pipeline, probably it was like 2 or 3 years ago or even more, the latest version of Ubuntu was 18.04. So here I can show you how you can do templates. So let's say that you have a set of tasks that you basically repeat across your pipeline, and you want to ensure that you will always perform that set of tasks in the same way, like I'm doing here. I want to ensure that I will always build my application in the same way. I can create a template for that. And then when I will be running my pipeline, I will be able to reference that template if needed, pass some parameters. As you can see, I'm doing it here. As you can see, I'm doing it here as well. And here as well. What I'm actually doing here, this is the pipeline that I was showing you with a bunch of different tests. So the application that I was creating here, that was the console application that meant to be a cross-platform application. So that application supposed to run on Windows, Linux, and macOS. And that was really important for me to ensure that I will have some test automation that will help me to validate that, because if I will need to, let's say, test everything manually, that will mean that every time I introduce a change, I will need to test it 3 different times. So what I'm having in my project, I'm having 2 sets of tests. I have the tests for the, let's say, the tests that are in the category of unit tests. And those tests, why they called unit tests, because they are always platform independent. What it means that they are running some .NET code, and that's it. And I also have a second set of tests, which I called integrational tests, because those tests are platform dependent. And when I'm saying platform dependent, as I was saying, this tool, this is the command line tool. So the platform dependent thing may be, for example, trying to talk to the file system of different operational systems, like trying to talk to the file system of Windows, trying to talk to the file system of Linux, macOS, and so on and so forth. So that is why I created a pipeline with 3 jobs that will run in parallel. The first job is based on Ubuntu. I will build the application for Ubuntu based on this template. I will then use another template to run my tests, and here I will first run the unit tests because they are platform independent, and also I will run the platform dependent tests for Linux. After that, I will do Windows. I will build the application for Windows, and I need to build this application again, unfortunately. And then I will run my tests for integration tests, I mean, for Windows as well. And then I will be doing the macOS. I will build the application. I will run my integration tests on macOS. So if you are creating something that needs to run on kind of a different operational systems, then this ability of being able to use the Windows, the Linux, and the macOS agents underneath, it's really, really important, because you can easily use that as your test form. And another example that I have here, but this is probably the example that I already showed. Yeah, this example I already showed, but anyway, I showed that for the GitHub Actions. Now I can show it for the Azure DevOps as well. So I'm also defining a strategy how I can parallelize my build run. I'm creating a metrics. I'm specifying that I will have the values for Linux, Windows, and macOS. The value is always the same, build platform. And this pipeline is a bit more recent. As you can see, it's using a different version of Ubuntu. But anyway, what I will be doing here, I'm ensuring that I have the .NET SDK installed, and then I'm restoring packages, building the application, and publishing the application, the CLI application itself. I'm copying all those files that I need, and I'm publishing the build artifacts. So the thing here is that when I'm doing that, I'm basically running the same flow. I'm building my binaries for 3 different platforms. So after that, if I will open this run and go to artifacts, I will have artifacts for Linux, macOS, and Windows. And now, the reason why I was actually doing that is to do the following. So GitHub, this one, yeah. Because after that, I can grab those and upload them to GitHub. This is the tool that I was talking to you about. As you can see, the last time I did something on that was 2 years ago. But nonetheless, those artifacts that were built with Azure DevOps, I was able to upload them here to the GitHub, and they are now available for everyone to download from here. Okay. Is there any questions or still no questions for this session?
I had a question.
Yeah, go ahead.
Yeah, so in the course of the CI pipeline, when you're building, let's say, for example, a React project, is there a way that you can catch? Okay, for example, there are errors and there are warnings. Warnings may be, for example, some features have been deprecated, but then the CI pipeline will still run and give you an artifact. So is there a way to be able to catch those warnings? Because I think with that, if you start getting those warnings, then it kind of brings some security issues in terms of now it makes your application vulnerable to attacks and something like that. So is there a way that you can implement in your CI pipeline to catch errors like those, so that maybe, for example, a CI pipeline fails or notifies you in case of those warnings? And
yeah, this is a really good question. I'm looking for an example. I'm not sure that I have that example, but let me just check a few of my sample projects. Maybe I will have it somewhere. Oh, yeah, I will have it here. So first of all, okay, I do believe that this is possible with the React. To be honest, I never tried that with the React, but I tried that with the .NET. So with the .NET, what you can do, I will show you how the .NET CLI works. Not the CLI itself, but yeah, this part. There should be a flag somewhere. I don't remember exactly when it was. Okay, I don't remember exactly, but with the .NET, for example, when you run your build, you can specify that you want to treat all of your warnings as errors. I can't remember the exact command that you need to run, but there is a way how you can do that. So if you will do that, what will mean? It will mean that when the command will run, if there will be a warning, the command will fail, and the default behavior is that it will automatically stop your pipeline. The thing that I want to show you here is, for example, for example, this guy here, rollback. If I'm not mistaken, this is the, yes. So this is again just a dummy pipeline, but this dummy pipeline illustrates what you are actually asking. So this is the pipeline, the dummy pipeline for deployments, but you will be able to get the idea. Okay, so I have a first job which I call deploy, and I'm running some scripts here. And now I have the second job warm up. It depends on my first job, and I can specify the condition to run that I will run that only if the deploy was successful. I have my second job rollback that also depends on a deploy, but I will run it if it's failed. And I have my last job notify, which depends on all of them, and the notify job will run always. So you can control that. You can say that, for example, if I run those tests, if the test failed, it should throw me an error, and then you can have a next job which will, for example, explicitly, I don't know, like send an email or roll back the commit or something like that. I mean, like you can do anything you want there. So yeah, you have the full control over that. And the other thing that I wanted to show you, I don't remember exactly where it was, but based on the name, let's try maybe this one. No, not this one. Okay, let me just open a regular pipeline and I will just modify a regular pipeline and show you what I'm talking about. So I can open any pipeline and for each action that I have here, I do believe that that was for each action, there is a set of predefined parameters. So one of them, continue on error, true. I can say that in case this particular script or this task or something else failed, then by default, continue on error is set to false. But in my case, as you can see, I can set it to true. What will happen in this case? In this case, we will have the third potential state of our build, because by default we do have two states of our build, either green or red, which means successful or not successful. If we have at least one continue on error equals true, then our build may end up with the yellow state. The yellow state means that one or more tasks failed, but those tasks were marked with continue on error equals true. Because this is another kind of an interesting thing, that if your tests are failing, it not always means that your application is wrong. If your tests are failing, it may be that someone, due to the new feature request or whatever, changed the code but didn't change the tests. So the tests are failing, but it means that you need to go and fix your tests. So that is why in some cases we can mark continue on error. We can use the continue on error to mark our test runs and so on and so forth. Yeah, I hope that answered your question.
Yes, it did. Thank you.
Cool. Do we have any other questions, guys?
Sorry, one more question.
Yeah, go ahead.
So, how instrumental is Linux commands? Because is there any other way of testing your code other than like writing shell scripts and writing like Linux commands to test your application? Apart from that, is there any other way that you can use to test your application? Okay, apart from unit, I'm talking about maybe integration tests after maybe the application has been deployed. And apart from maybe using curl and other maybe Linux commands, is there any other way that you can use to test that?
This is a really good question because answering that question, I will be on a really what they call it slippery slope, because in one hand, if you will check the built-in gallery of all the different tasks here, you will see that this gallery is actually huge. And this is only those tasks that are built in. What you can do, you can go to marketplace.visual something like that, if I'm not mistaken, marketplacevisualstudio.com. Here you can choose Azure DevOps, and here you will have even more pipelines that you can basically download to your Azure DevOps account and use them, even more plugins that you can download and use. But despite all that variety of tasks, when it comes to pipelines, I still recommend to use CLI. I still recommend to use some good old commands from the command line. And the reason for that is because it will be much easier for you if needed, like to switch from one system to another. That's the first thing. So if today I'm working with Jenkins, tomorrow I will need to work with the Team City, and then the day after I will need to work with Azure DevOps or something like that, and I can name a lot of those different systems. If I will stick to those command line commands, it will be super easy for me to go and work with all the different automation platforms. Because let me show you this. For example, let's again use Docker. Okay, so Docker, for example, okay, I need to connect it, but anyway, let me just add a Docker task. Okay, so here I've added a Docker task, and as you can see under the commands, I have build and publish. So technically, when you are working with Docker, you don't have a single command for build and publish. You need to use two different commands. You need to run your build first, and then you need to publish it. So with Azure DevOps, and the same goes with the GitHub as well, it can simplify those things for you. But what I will be really afraid of is when I see the task like this, it's kind of easier to work with that. But on the other hand, I don't have the full understanding of what is happening underneath. And I'm really, really afraid of that, because in one hand, when we're talking about Microsoft as an ecosystem, the Microsoft ecosystem is all about making those hard things simple for you. I mean, like, that's the general direction that they are trying to follow. But on the other hand, if this thing is simple for me, I don't have a decent understanding of how it works underneath, and that can be an issue. I can give you an example, actually. I can give you an example not related to this topic at all, but maybe that will help me to make my point. And again, I'm not saying that my point is the only one correct point. Not at all. I mean, like, you may have your own opinion, and your opinion may be even more valid than my opinion. I'm just explaining to you why I believe that this is the best option for me personally. Let's say that I'm driving a car. Okay, let's say that I'm driving a car from one city to another, and somewhere in the middle of nowhere, my car breaks. Okay, in that case, I have like two options. I can either go outside, call for help. I mean, like, call for a service. They will basically send me a tow truck and something like that, and then they will tow me to the nearest service station, and so on and so forth. But if I have at least some basic understanding on how the engine works, what I can do, I can open the bonnet, I can take a look at my engine. Maybe I will be able to do some easy fixes. Maybe the car broke because, I don't know, because I have like a hole in my radiator, and I just run out of water, so now it's not starting because the engine is overheating. So I can potentially easy fix that by just adding a few liters of water to the radiator, wait a bit for my car to cool, and then I can continue to drive. I don't know, but the idea here is the same. I always prefer to use command line because I have a better understanding, and if I will need to fix something, I will not need to go and, like, learn how this task is working underneath. Of course, I always have this button about this task, which will basically direct me to the documentation. But yeah, this is the perfect example, because on that particular task, that link is broken, and it sends me to the root page of my documentation, which is basically pointless. So yeah, this is my motivation behind it. And you were talking about the different kinds of tests. Let me show you another example. Maybe I have it here. This is one of my other projects. No, wait a sec. I made a typo somewhere. Yes, this one. The ALF project. This is my personal project, so that's why I can show you basically what is happening here. If I will go here, I don't remember exactly. It was maybe in one of those pipelines. Let me check. Oh no, sorry, that's the infrastructure template. No, it's not that. Yeah, maybe that part was not migrated. So let me show you the following. So a long time ago, like really long time ago, I was actually trying to avoid showing you this. Microsoft used to have a graphical interface that you can use to basically create your build pipelines. So I can click on the plus. I have the same set of tasks. I can pick a task. I can click add. I can rearrange them here and so on and so forth. But nowadays, I recommend not to use that approach in your new projects. If you already have that in your old project, that's fine, but still please consider migrating to the YAML pipelines. What I'm having here the Newman integration tests for my API. You were asking about how we can test the application. So what the Newman is, I'm not sure are you aware of it or not, but you're probably aware of the other tool. You're probably aware of a tool called Postman. If some of you are not aware about that tool, so this is the tool. This is the free tool. They also have like a paid pricing tiers, but nonetheless, you can also download it for free. And this tool, it allows you to create basically those HTTP requests and send those HTTP requests from the tool. You can control all of the parameters of those HTTP requests, and it's a really cool tool if you need to explore the API. And what they can also do, you can, for example, grab a set of requests and you can, as you can see here, you can actually export those requests in a collection. So those requests that you configure here, you can export them in the collection. As you can see, I have a bunch of different requests for that ILF project I was talking about. I also have a bunch of requests for some other projects and so on and so forth. And in addition to that, when you basically exported those requests as a collection, for each and every request, there is a tab here called test. And what you can do, you can basically create a testing script. And with that testing script, it will run your actual request from the collection. It will get the response, and then it will try to validate that response according to the code that you specified here. And in that way, what we were able to achieve, first of all, we were creating a collection of Postman requests that we can share through our source control. We can share that across the whole team. So every new developer that came to the project was able to download that collection and explore the API. The second thing is that we were also creating those testing scripts here. For example, as you can see, there are a lot of snippets here, and let's use this snippet. For example, this is one of the snippets that will ensure that when I will call this API, I am expecting that the response status will be HTTP 200. And we were having a bunch of those tests here as well. And what we're able to do, we are able in our Azure DevOps, and not only in our Azure DevOps, to use another tool called Newman. Newman is a tool from the same team that creates Postman, and the only goal for the Newman is to run those tests from the CLI, because I mean, like, I can easily run those tests from my UI, but if I need to automate that, I need to have a way that I can run those from the CLI. So I can run with the Newman, I can run those from the CLI. First of all, I need to run this command npm npm install Newman to install Newman to my machine, and then I run npm run Newman test, because this is the command that I have in my package.json file, and it will run that test automation. And maybe I will also be able to show you some of the results from the ancient times. Maybe this one will have something. Let me check. Yep. This is 2 years old, but still have it. As you can see from the logs, so I was trying to run Newman run, and everything appears to be successful. And here I have tests, and as you can see, 68 tests passed. It took him only 6 seconds. If I will clear this out, collapse this guy, you will be able to see what those tests were about. But as of an automated way of testing your application, I'm not sure that there is a tool for that, because technically only you know how to test your application. Only you know the context of your application. Because, for example, if I will go to main page of the website, and that main page will respond with something like 404, will it be an error or will it be an expected behavior? Because it can be expected behavior if there is no main page. If the website that I'm creating is a set of, I don't know, some kind of a private workspaces, so that's why there are no root workspace, there is no root workspace, and I always need to go slash something something, and then I will have not 404 but a login page or whatever. So that is why talking about testing, yeah, it really depends on the application that you are creating. I know that I know that I probably didn't answer exactly your question, but what I wanted to show here is that you can run any kind of test with the command line. And yeah, the only thing that you need to remember is that if you want to test the API, first you need to deploy that API somewhere. So yeah, as you can see here in my application, I was deploying backend, I was deploying frontend, and then I was running my test. Those tests, they were checking backend only, but nonetheless, you always need to remember about that.
All right, thank you. I think you addressed it. You kind of addressed it. So thank you.
Yep. Awesome. Do we have any other questions, guys? Okay, I will take that as no. If the clock on the Teams timer is correct, then we were spending almost 2 hours together. I know that we waited for like 10 minutes at the beginning, but nonetheless, now we have a bit less people that we had at the beginning, which is okay. I do believe it's not an easy job in general to spend 2 hours on a webinar like that. But anyway, I want to say thank you to all of you who joined me on this session. I want to also say thank you to the organizer who actually helped us to gather here today. I do hope that you enjoy the session. I will be extremely appreciated if you will provide a feedback, what you like, what you didn't like, what you believe needs to be changed, and so on and so forth. And yeah, I really hope that you guys will invite me to some more sessions somewhere in the future. On that one, that was it. I have nothing to share for now. So yeah, have a great day and see you later. Bye bye.
Yeah, thank you, Anton. I appreciate it. We're happy to have you next time. Yeah. Thank you.
Thank you guys. Bye.
Yeah, bye,
Bye.
guys.
Bye. Um, Anselmo, Winnie, can you guys stop the recording so it doesn't get messed up like the last time?
Yes.